All right, this problem is a little more abstract. We're just asked to use this table um, to give an upper and a lower estimate for the integral from 5 to 30 of this function f of x. Now we only have f of x as, as a table. So, but we want the integral from 5 to 30. Okay. So, and we're going to estimate that with left and right hand sums. So, okay, if we're going from 5 to 30, right? We're trying to find 5 to 30. We really don't need this, I don't think, right? Because we're going to start at 5 and we're going to go to 30. All right, so we have to be careful, with the information. If we only want an estimate from 5 to 30, right? These are x values, right? This means x equals 5, and this means x equals 30, right? So I want to integrate from 5 to 30. And if I look at this, I've got 1, 2, 3, 4, 5 subintervals, right? So n is equal to 5. That's as good as I can get. And my delta t, or delta x, I guess, because it's x, delta x is 5. Okay. So my left-hand sum will be L5. Okay. I'm going to multiply by 5 because that is my delta x. And then I'm going to add up the first 5 values of f of x, right? Because those will be the values on the left-hand side of each subinterval, right? So I'll have 16 plus 23 plus 27 plus 30 plus 32. Okay. So what do I get? If I put that in my calculator, I got 640. Okay, now this is a very abstract problem. I don't know what this function represents. So I'm just using left and right hand sums to estimate this integral now. All right, now if I want the right hand sum, again, it's going to be R5. The delta x is still 5. Okay, so remember, this is delta x. All right, now they happen to match. This is n. This is the number of subintervals. Now they happen to match in this case. So, but now I'm going to, for each subinterval, I'm going to use the value of f on the right hand side. So I'm going to use 23 and 27 and 30 and 32 and 33. Right? I put that into my calculator and I've got 730. 730 is my estimate. Now, once I've calculated this, I can tell that, the left-hand sum is giving me a lower estimate. That's my lower estimate, and this would be, of course, my upper estimate, right? Because obviously the 730 is bigger than 640. Now, for in the last example, the left-hand sum was giving me an overestimate, right? So that was giving me an upper estimate. And in this case, it's giving me a lower estimate. And why is that? Why is that? So this is an increasing function. So over each subinterval, the left-hand side is lower than the right-hand side. So the left-hand sum is going to give me a lower estimate. And the right-hand sum is going to give me an upper estimate because over each subinterval, the right-hand side is higher than the left-hand side. All right. So, it's really because this function was increasing, and whereas the function that we had for the oil leak before was decreasing. All right. So, now that's all I really need to do. Now you can see that I can get a better, it doesn't even ask me to do this, but I'm going to do it anyway. Average. If I average these two, I'll get an even better estimate, right? Because I'll get the value that's right in between. I know 730 is too big and 640 is too large. So if I pick the value right in the middle, which is the average, I'm just going to take 640 plus 730, divide that by 2, and I get the average is 685. So it didn't ask me to do that, but sometimes I do ask questions that ask for the average of the left and right hand sums, and so this would be a little bit better estimate when I take the upper and the lower estimates and average them. All right. Well, I'll see you in the next video.